The primary objective of doing this exercise is to show you the intuitive way of getting this statement. So what I essentially do is I again write it in a different form. Every time I do a revision, I will show you something different. So this time what I use is I use the notation of summation. So this summation in fact essentially means that I repeat 1 plus 2 plus 3 plus 4. In a future video, I will definitely show you several notations. For example, we have a notation for summation, we have a notation for product, we have different notations in higher mathematics, and I will one day show you all these notations. But for the time being, let's assume that this means 1 plus 2 plus dot 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 up to n. So what I need to show is I need to show the intuitive procedure of showing that 1 plus 2 plus dot 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 plus n equals n times n plus 1 by 2. So what I do first is I take case 1 and I see, and what I do is I write down all the numbers. Maybe not all the numbers, but at least some of them. So I write 1 plus 2 plus 3 plus n. If n is even, that means I have an even number of terms here. So that means half of the numbers are from 1 to 3, 4, 5 up to n plus 2. And then we have the other half of the numbers. So if n is, let's say n is 4, that means I have two numbers here and I have two numbers on this side. This line essentially divides the numbers into two equal halves. The number of numbers, not the numbers itself. So what I've done is I have divided these two numbers, and what I take is in the next line, I take the first number and the last number and I put them together. Again, I take the second number and I take the second last number and I put them together. Similarly, I take the third number and I take the third last number and again I put them together. Going on, you will notice that the nth pair will have n plus 2 plus n plus 2 plus 1. So I will be taking this and I will be taking this. That will give me the nth pair, because for every number that I have, I'm getting one pair. So that's the first pair, second pair, third pair. Similarly, we'll get to the n by 2th pair. Sorry, I'll get to the n by 2th pair, which will essentially, n by 2th pair will essentially mean that I have n by 2 times 2. So I have n numbers in total. So now if I add every single pair as follows, what I get is I get n plus 1. If I add these two, I get n plus 1. If I add these two, I get again 1 plus n. Similarly, for every pair of number, I'll get 1 plus n, and these are n by 2 in number. So I have n by 2 such numbers. So doesn't that essentially mean that I'm adding 1 plus n by 2 times? Doesn't that again essentially mean that it's n plus 1 times n by 2? So there are n by 2 number of n plus 1s, which essentially means that it's equal to n by 2 times n plus 1. So that's one way of putting it. The other way is if I take case 2 where n is odd. I'll take it as a shorter procedure. I will again, what I do is this time n is odd, which means I won't be able to break it into two parts as such. But if n is odd, this will imply that n minus 1 is even. So this is the concept that I'll be using. I have 1, 2, 3 up to n terms. If I exclude the nth term, then up till here, I will have even number of terms. N minus 1 are even number of terms, which means I can break it into two parts. So this part will have n minus 1 by 2. You see, when I had n terms, my middle portion was denoted by n by 2 and n by 2 plus 1. So if I have n minus 1, then the number preceding half will be n minus 1 by 2, because n implies n by 2. When I am considering n number of terms, this term is n by 2. So when I'm considering n minus 1 terms, this will be n minus 1 by 2. And naturally, this will be as similar to the logic that I had discussed before. It will be n minus 1 by 2 plus 1. So that is how I have divided n minus 1 terms into two equal portions. Then again, I repeat the steps that I've done before. I take the first number and last number. I take the second number and I take the second last number. So if I do that, let's say let's take a different color this time so that it'll be easier for you to understand. So let's take blue. I take the first number and I take the last number. So that's 1 plus n minus 1, which gives me n. Again, I take the second number and I take the second last number. So that's 2 plus n minus 2, which again gives me n. So I'll take the third number this time and the third last number, which will give me 3 plus n minus 3, which is again n. And in this way, I will get n minus 1 by 2 pairs. And I'll exhaust these n minus 1 terms. And finally, I'll be left with this nth term, which is n. So that will that will be the next line. So as I told you, I will have n minus 1 by 2 pairs. So that's n times n minus 1 by 2 plus the nth term. What I do next is I take n common, then I'm left with n minus 1 by 2 from the first term and 1 from the second term. If I do the calculation, n stays out, the 2 in the denominator comes out, and I'm left with n minus 1 plus 2 on the numerator, which gives me n plus 1. So whether n be even or odd, I am always getting the fact that 1 plus 2 plus 3 plus up to n will always end up with n by 2 plus n plus 1, n by 2 times n plus 1. So this is an intuitive way which does not use any information of AP series or any mathematical induction concepts, and it's a very simple, a very lucid, and a very very easy procedure that even a layman can understand. And I really like this procedure, so I wanted to share it with you guys.